Hello, my name is Felipe Treviso. I'm here to present this work called Multiple Delay Identification in Long Interconnects via the least square support vector machine regression that was supervised by Professors Flávio Canavero and Ricardo Trinqueiro. And the motivation for this work is that interconnects are responsible for a considerable part of signal degradation. When two devices are communicating through them, such signals will suffer effects such as distortion, reflection, and crosstalk. And in order to predict the signal integrity of the channel during the design phase without requiring expensive prototyping, it's essential to have good interconnect models. But while that linear interconnect is usually characterized via simulations or measurements in the frequency domain, it is connected to nonlinear transceivers that need to be simulated in the time domain. And so the model should be adequate both for time and frequency domain at the same time. The usual way to model the interconnect is via rational models, which is a linear expansion of rational bases with poles and which have an equivalent circuit made of capacitors, inductors, and resistors, and thus compatible with transient simulations. However, for long interconnects, these models have a large number of poles, slowing down the simulations. A way to reduce the number of poles is to use instead delay rational models, which is similar but considers explicitly the delay of the interconnect. However, it is unpractical to estimate both the poles and delays in this model together, and therefore you need a method to estimate them separately. First the delays and then the poles. So in this work, I developed a framework based on the least square support vector machine that considers a delayed rational model with an infinite number of bases. The cross-validation and optimization of this least square SVM model identifies the region where the dominant propagation delays are located, and the analysis of the resulting model provides the delays, which are accurate in comparison to existing techniques. And the approach to achieve that is by making the primo space model of the least square support vector machine equivalent to a delayed rational model with a constant term, delayed rational basis in both, and the weights proportional to the residues of the delayed rational model. So these weights are used then to identify the dominant delays of the system. Then we can estimate the model with an infinite number of bases by using the dual space formulation, where the number of unknowns is the number of training samples, no matter how many bases we are using. And so with this, we are able to build this model and analyze the weights to identify the delays. To exemplify that, we can apply this method to the transfer function of this structure with multiple transmission lines and lumped components. We use 900 samples to train the model in 15.6 minutes and use another 101 different samples to test the model. The resulting model is accurate, as you can see here, and also in the detail of some of those samples to see that the accuracy of the model is good. Now I will show some more details about the delay identification and compare to previous literature. So from that previous model, we are able to identify the dominant delays as peaks in this curve here. And we can compare them to other techniques available for this and see that they are accurate, with the advantage that we can find multiple delays and have a proven method to tune the parameters, which is the cross-validation, while also optimizing the interval where the delays should be found. To conclude, this method opens up a lot of possible future work because of its flexibility. For example, on the choice of the poles that we use in the least square support vector machine model, the use of multiple delay intervals, or by adding new information about the system whenever we discover them. Additionally, we can have a parallel model with infinite bases for systems without delays, or we could add additional design parameters into the model. Here are some references highlighting these two publications about this work from last year, which were published in IEEE Access and on the SPI conference where it received the Best Student Paper Award. Thank you very much for your attention.